So if you recall, our current project is solving oblique triangles, that is non-right triangles. Our standard triangle will have angle alpha opposite side A, angle beta opposite side B, and angle gamma opposite side C. And we had three tools to solve for various parts of our triangle. Just like we had three tools when solving right triangles. We have the sum of the angles is 180 degrees. Our other tool for solving oblique triangles is the law of cosines. Which is our generalized Pythagorean theorem. I like to think of this as the general Pythagorean theorem because it helps me remember what it looks like. We start off by writing the Pythagorean theorem. C squared is equal to A squared plus B squared. But then there's that additional term, minus 2AB cosine gamma. And then I just have to permute B into that first position and then A into the first position. So the other permutations would be B squared is A squared plus C squared minus 2AC cosine beta. And then move the A squared over there. A squared is B squared plus C squared minus 2BC cosine alpha. We also want to be able to use the law of cosines to solve for an angle. So we could rewrite this for gamma by saying it's cosine inverse of A squared plus B squared minus C squared over 2AB. So we did that last time. Solve this equation for gamma, and then beta, and then alpha. And we just want to recognize the patterns. So gamma is cosine inverse A squared plus B squared minus C squared over 2AB. Once we can solve one of them for gamma, or for the angle, we can solve all of them for the angle. We just need to permute things through. So if I wanted to write beta, beta is cosine inverse of, then the numerator will be A squared and C squared minus B squared over 2AC. And we could use this to solve for alpha. Alpha would be the cosine inverse of the two that aren't the same, that don't match, B squared plus C squared minus the opposite one, A minus A squared over 2BC. So it looks like 6 things to remember, but it's really only one, and it's a variation of something that we already have. Pythagorean theorem, C squared is A squared plus B squared. Modify that with our minus 2AB cosine gamma. Permute through the B and the A. Solve for gamma, solve for beta, solve for alpha. It's really only one thing presented 6 different ways. And it's source of the Pythagorean theorem. So we got to think about when we can use the law of cosine. Well, in the angle column, we can see that if we have all three sides, that looks like a job for the law of cosine. So if we look at the stuff that we need over here, we need all three sides. So it's the law of cosines if we have all three sides. Once we have all three sides, we could use the law of cosines 3 times to find each of the 3 angles. But we should always remember that as soon as we have 2 angles, we just subtract to find the third. So you use the law of cosines for gamma and beta, but then you should just subtract to find alpha. Over in the other column, we can use the law of cosines if we have 2 sides and 1 angle. The way we're going to characterize this 2 sides and the 1 angle is that the angle is the included angle. So notice angle gamma is included between sides A and B. Angle gamma is made up of A and B. Angle beta, the 2 sides making up angle beta are A and C. And the 2 sides that are making up angle alpha are B and C. So if we have 2 sides and the angle between those sides, 2 sides and the included angle. So if we have 2 sides and the included angle, we'll use the law of cosines. So here's how I think of this. And you might find this useful too. This is not the way. There are usually many ways of thinking about things, especially when it comes to thinking about things. I don't know how you are going to train yourself to remember these things. So all I can do is put out the various ways I know people do remember these things. So notice that if we have all 3 sides, I've got an A, a B, and a C. So I got a full set. In my mind, alpha and A are paired together, beta and B go together, gamma and C go together. So all 3 sides looks like a full set of things, A, a B, and a C. Have an A, a B, and a C. And I could use that to find any of the angles. In the case of 2 sides in the included angle, I have alpha, A, B, and gamma. Or I have A, beta, and C. Or I have alpha, B, and C. So when I look at this set of information, A, B, gamma is related to C, I think of this as a full set of information. The variety pack. So I think of these as full sets of information. An A, a B, and a C. If you replace one of those with the corresponding angle, alpha B C, A beta C, A B gamma. That's a full set. We've got one of each of the things. That means law of cosine. We don't have to think of it this way. You could always just say, what can I use? And use that to determine. But if you have all three sides, law of sines is out. It's the law of cosine. If you have two sides of the included angle, whether you learn to recognize that or not, that's the law of cosines. The way to recognize side, 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 or side angle side is to look if you have a full set, an A, a B, or a C. Now, this is all the decision that we make when we only have three pieces of information. As soon as we have four, then it's off to the improvised solo. Our third tool is the law of sines. The law of sines says that the ratio of the sine of an angle to the side opposite that angle is constant in any triangle. The ratio of the sine of an angle, the side opposite that angle, is constant in any triangle. We summarize the three equations in the law of sines in one equation. The ratio of the sine of an angle to the side opposite that angle is constant. We can use the law of sines to solve for angles and solve for sides. The situation when we use the law of sines is dependent upon what we're looking at. Notice that what we need for the law of sines is a set of opposite information, A and alpha, B and beta, C and gamma. So for the law of sines, we're looking for opposite information. Maybe a better word would be opposing. So we have A and alpha, B and beta, or C and gamma. To use the law of sines, I need that opposing information. I need the side, the angle, and the side opposite that angle. Then any third piece of information. Notice that that's not the case when we have the full set. The full set is an A, a B, and a C, no opposing information. So those are the two cases. The overall rule for which law to use is which law can you use? You don't have to think about it too much. Which law can you use? In general, we will want to use the law of sines. As soon as we use the law of cosines once, then we have four pieces of information and we are guaranteed to have a set of opposing info. And so if we train ourselves to want to use the law of sines, once we use the law of cosines, we can switch to the law of sines. But if our starting information doesn't have a full set, we have to use the law of sines. So we don't have to worry about classifying things. But I mean, it's a math class, and man, do we love to classify things. Now, the way we use the law of sines is we can either solve for an aside, where I could say A is B sine alpha over sine beta. Or I could solve for A with gamma and C. A could be C sine alpha over sine of gamma. The important thing to note is that the opposing pairs are always on top and bottom. They're never mixed together. You're never going to have B sine beta. You're not doing proportions right if you have B sine beta. If you're using B, then sine beta is going to be in the denominator. We can also use this to solve for an angle. But to find an angle, we have to use inverse trig functions. So if I want to solve for alpha, that will equal A times the sine of beta divided by side B. Once again, notice that sine of beta and B are on different parts of the fraction. If I want to solve for alpha using C and gamma, it would be the sine inverse of A sine gamma over C. So there's really not much question. Once we understand how law of cosines and law of sines work, there's really no question as to deciding which one is which. We don't have to classify in terms of case. We can just start solving, and we start with whatever we can use. If we are supposed to use the law of sines, we won't be able to use the law of cosines. If we're supposed to use the law of cosines, we won't be able to use the law of sines. So you don't have to worry about that. You just have to learn the two laws and then practice using them. How's everybody okay? This is how you can tell it's a rough day and you don't really want to be at work. You're on your way to your class, and you go to adjust your mask and it breaks. Because we're all just wearing, like, so snap. My first instinct was like, oh man, I guess I can't have class. And I'm like, oh, come on, man. I know you're lazy, but that's pretty excessive. Especially when there's a whole box of friggin' masks in the room. And there's another box of masks right by the doors. So if that's empty, then you get that one. There's one in here. You know what I mean? Then you start justifying it. You're like, oh, but then I have to walk into the building without a mask. And then I remember, like, oh, no one will. Especially if I walk in, I'm like, oh, I can't have class today because we're out of masks. And then some student will be like, oh, but there's a mask on the desk. I'm like, oh, can't do class. Bye. That's a day where I, like, seriously didn't want to be here. You know what I mean? Fortunately for our heroes, I have my spare mask, my backup parachute. But if this one breaks, then, I mean, I'm just going home. Any questions? I knew that this was going to happen too, because this is week 8. We're like halfway. And so on one hand, it's like, oh, all right, halfway. And on the other hand, we're like, ugh, only halfway. You know what I mean? And it's not actually halfway today because it's 17 weeks, so 8.5. We have to get past the halfway of this week. Then we'll be on the other side. But that first week is shorter by 2 days. So maybe today is the halfway. So, two things to notice about this example. Suppose we know that side A is 15, angle alpha is 37, and angle beta is 105. One thing that we want to point out is that the law of cosines is not available to start with. We cannot open with the law of cosines. I don't have a full set of information. I've got A and alpha and beta. I don't have like an A, a B, a C. I've also only got one side, and the law of cosines we saw requires at least two sides. So law of cosines not available. Can't mess it up. We cannot put this information into the law of cosines. We do notice that we have side A and angle alpha, and that tells us that we can use the law of sines, but it's not the first thing that we're going to do. Because we'll notice that the first thing we should do is subtract. As soon as you have two angles, subtract to find the third angle. So the A and the alpha, this means the A and the alpha means we could use the law of sines. But we're given two angles, so we should subtract to find the third one. Since we're starting with two angles, we should subtract to find the third. That should always be the first thing that we do as soon as we have two angles. So I'm going to start by finding gamma. Gamma is 180 minus 37 minus 105. The other angle is 38. That tells a few things. With alpha at 37 and gamma at 38, we should expect side C to be kind of close to side A. And side B ought to be the biggest side. Now we have an abundance of information, but we still don't have two sides, which means law of sines is the way. We got to use the law of sines, and we're going to have to use A and alpha. So I'm going to set up the law of sines with the sine of 37 over 15 is the sine of one of the other angles, 105, and that would be over side B. I'm using the law of sines to find a side. So B is 15 sine 105, close parentheses, divide by the sine of 37. We should expect that B should be bigger than A. B is opposite a larger angle. So we should expect side B to be larger than side A, and it is. So at least it passes that reality check. The last thing we have to solve for is side C, and we could use the law of sines again. So I'm still going to use sine of 37 over 15 because that's given information. I could use sine of 105 over 24.1. I favor that less because the 24.1 has been rounded. However, if we're careful, it won't matter. Well, let's just use the given information as a best practice. Another good reality check. The angles alpha and gamma are close in value, 37 and 38 degrees. We should expect side C to be a little bit bigger than side A, and it is at 15.3, bigger than 15.0. So at this point, we'll point out that we could have also used the sine of 105 over 24.1 is equal to the sine of 38 over C. So C will be 24.1 times the sine of 38 divided by the sine of 105. And we get to say, we get 15.4. That's if we use the rounded 24.1. If we use more digits, so 24.075. If we just use one more decimal place, then it'll round in the right direction. One thing to note, if we're going to use the 24.1, the situation that we're in is we did 15 sine of 105 divided by the sine of 37. So 24.07531,689. We could use that whole thing if I just say answer times the sine of 38 divided by the sine of 105. That way, I didn't use any rounded information at all, and I got exactly the same as the 15.3451171. My recommendation is that you use as much given information as possible. But when you're using rounded information, either use the keep all the digits functionality of your calculating machine with the ANS key, or just make sure you type in more digits than what your rounded answer would be. 24.1 was enough to throw us off in this particular problem. Any question? Comment? Have your mind. How's everybody okay? One of the fun things about wearing masks in class is that it makes it just that much harder to read expressions. I mean, no one puts up any different expressions anyway in math class. As soon as you walk in and math class starts happening, everybody just goes from like wherever you were before to just kind of like this numb staring. So no matter what's going on, I look out and everybody's kind of like, with masks off, it looks very noticeable. You're like, oh, and you don't even realize it. But the mask covers all that up. So the funny thing is that sometimes something will be mildly funny and you'll think you'll be laughing at it, but this is what you look like when you're laughing in math class. And usually the most you ever get is like, oh, and that's like the limit of it. You know what I mean? But now, even if you do make an expression with the lower half of your face, it's like, no. So everything, it just like emphasizes the just like being stared at thing when you're a math teacher. Just like hashtag math teacher life. Questions? The first part of this problem was determined for us after we got the two angles. Let's take a break and look at the and we'll look at the fourth thing that could happen with given information. Let's take a break.